In this video, I would be discussing the second and third problem of today's lead code contest. Actually, the question B and C of the today's lead code contest was the same. The only difference was in their constraints. So in the question B, it was very less. So h dot length was less than equals to 50. Whereas in the problem C, it was 10 to the power 5. So we would first discuss the brute force and we'll try to optimize for the constraint 10 to the power 5. Okay, so this was the question B. So let's first understand the problem. So you will be given a string s. You will be given a string s of length n, and that consists of lowercase English letters, and a string is special is called a special if it is made up of only a single character, that is like this. A string of the same character would be called special in this problem. Okay, so we have to return the length of the longest special substring of s which occurs at least thrice. So we have to return what is the maximum length we can get of a special substring uh, having frequency of occurrence greater than equals to 3. And if there is no such special string substring, so we have to return -1. So let's see the first example. You can see here the string here is a. Okay, so the maximum length would be 2. Why? Because see here, this is a special string of obviously because it is consisting of a string of character a, and its length is 2. And if you see that the occurrence of the same special substring is equals to 3, first, second, and third. So you can see the length would be 2. Okay, so if you try for 3 of length 3, then this is the first substring and this is the second substring. But you can see the frequency of occurrence of this special substring is 2. So this would not be applicable because we have been like explicitly told that at least thrice. Okay, so the special substring should occurs at least thrice. So the maximum length we can get is answer 2. Okay. Similarly, for this one, there is no character which is occurring greater than one time, more than one time. So obviously the answer would be -1. And in this case, the answer would be 1. Why? Because you can see the special substring of length 1. Either you can take a, yeah. If you take substring of character a, then you can see that the maximum length which is occurring at least thrice is a. So that's why the answer is 1. Okay, so I hope the question is clear to you. So obviously for this problem, since the constraint is very less, less than equals to 50, so we can go for the brute force. So let's move on toward the Canva. So my brute force is like that. What we will do is that I will try, I will try for every possible length. Okay, for every possible length. So I will start from the length. Suppose n was the length of the string given. Okay, so I will start from length is equals to n minus 2. Why n minus 2? I will tell you. So suppose there is a string of substring. Suppose it is a special substring a. Okay, so what can be the maximum length? Just hear me properly. What can be the maximum length of a special substring which can be created using this substring of length 4? If you just and having greater than equals to frequency 3, frequency greater than equals to 3. So you can see here that it is 2. See, the frequency is 3. Okay, frequency of occurrence is greater than equals to 3. So what I am telling you is that I will try from, so you can see here the length was 4, and the maximum length of the special substring we are getting is 2, so it is n minus 2. Okay, even if you consider like this one, so obviously, uh, why I am getting the intuition n minus 2, because suppose this was the last character of the last occurrence of the substring. So suppose here it was, and this was the last one, and this was the second last one. So obviously, we should be having at least two extra characters for getting frequency greater than equals to 3. That's why I am taking n minus 2 as the maximum length. Okay, just try with this also. If we are given length 5, so we can see here the length would be 3, maximum length, such that the frequency of occurrence is greater than equals to 3. Just see here, the see 1, 2, and 3. So obviously it is n minus 2. Okay, so what I will do is that I will try for every length is equals to n minus 2, length greater than equals to 1, len minus minus. For every length, what I will do is that I will try I will try for every character, like from A to Z. Means what I am telling is that suppose I am considering for the special length 4. Now what I will do is that I will try for every special substring of length 4 with every characters, like uh, first would be A, then B. I will try for B, then like this Z. So I am telling this. So that's why this would be a second loop. This would be a second loop. And now for every character, I will keep a counter of occurrence of length this len. Okay. So I will start from the I is equals to 0, I less than equals to n minus l, I plus plus. Why I am taking n minus len? Suppose I am having a string of length n, then the number of substrings of length len would be n minus len. No. So why I am taking n minus len? Why am I iterating from up to n minus len? I will discuss here. See, 0, 1, 2, 3, 4, 5. Okay. So suppose the n was 6 and len was 3. Means I am trying for the length 3. Okay. So you can see up till which index we can try for a substring of getting a substring of length 3. You can see here. You can see here n minus up till index 3. And what is 3? N minus len, which is 6 minus 3. So that's why I have done n minus len and I plus plus. Then I will try to get I will get the string str substr starting from I of length n. Okay, and I will compare it with if str equals to string string of this character which I am considering, suppose C, it is C, and then it is len. If it is equal, then I will count plus plus, and if the count is at least 3, then I will return this length, because I am starting from the maximum length to the minimum length. So what is the time complexity? Talking about the time complexity, it is maximum n, then it is 26, then you can also take it as n minus len. So also take it as n, and compare for the comparing string it is n. So n cube into 26. So which is quite acceptable because n is less than equals to 50. Okay. So let's first code it, then we will move on towards the optimal solution. First of all, I have taken the size of the string, then I'll initialize as answer is equals to -1. Then what I have told you that len is equals to n minus 2, len is equal to 1, len minus minus. Okay, so I will try for every character for char c is equals to a, c less than equals to z, c plus plus, and for each special string of length len, I will keep a counter of occurrence. Okay, if si is not is equals to c, then obviously it doesn't make sense of comparing. Okay, so in that case I will continue, and if string str is equals to s dot substr, starting from the I will store substring of length len. If str equals to string of c comma len, means what I am doing here, uh, I am creating a string of having character c and of length len. Okay, if it is so, then I will increment the count. Okay, if count is greater than equals to 3, then I will return len. Why I'm returning from here itself? Because I am starting from the decreasing order. Okay, so obviously it would be the maximum possible answer. Return answer. Sorry, like why it is so. C less than equals to z and minus len and I plus plus I have done I comma len, then oh sorry, I have actually length and c, means I am creating a string of length len and having character c. Yeah, it is giving correct answer now. Let's submit it. Yeah, it got accepted. So let's move on towards the problem C, which was the same problem, but the constraint was somewhat like constraint 10 to the power 5. Okay, you can see here. So how we can optimize it? How we can optimize it? So what overhead we were doing in the previous solution? First of all, we were checking for each length. We were checking for each length, which should be optimized, which was an overhead. Obviously, if I know why I'm saying that it is was an overhead for checking for each length, because suppose if I have checked for length len, okay, suppose L1, and if L1, if there is no substring, special substring of length L1, so does it make sense to check for the length L2 such that L2 is greater than L1? Does it make sense? Obviously not, because if I am not getting a substring of length L1 which is less than L2, so why would I go for the length L2? So here you should, and similarly, suppose I am getting answer for the L1, and then why I would check for the length L2 if L2 is less than, if L2 is less than L1, if L2 is less than L1. Suppose I am getting a substring, special substring of this length, then why I would check for this length? Obviously, this would also satisfy a frequency greater than equals to 3, means frequency of occurrence greater than equals to 3. If this is satisfying, then this substring will also satisfy. So from here onwards, from this I got the intuition of the binary search. Okay, okay. So now I have got the intuition of the binary search, that I will apply binary search on the maximum length of a special substring. Okay, but now the next question which comes, how to check for a substring of length L optimally. Because if you just see the previous solution which we have done, for the checking also it was n square solution. For the comparison of the string, it was it was taking n, and for the iteration part it was taking n. So obviously it would become n square log n, but obviously it would not be accepted. So I would tell you one thing, that whenever you have to optimize and like time complexity is not compatible, then you should go for some pre-computation. Okay, for the optimization. So what pre-computation we can do? Suppose you are given a string like this, a and b, then again a c b. Okay. Suppose I am available with Uh, suppose I have created a unordered map or hash map, okay, of like for each character A, B, C up to Z. I am having a level with the length of the substring I can get use of from this substring. Like what I am telling you is, for this string S, for the special substring having character A, what I will store? Length 4. Okay, length 4 you can see here, then length 2. Okay, I hope it is clear now what I am trying to tell you. Like I will store the length of the special substrings I can get from the string S having character A. Similarly, for the character B, I can say that it would be of length 3 and again 2. Okay, and for the C, it would be only 2, because here I can see that it is 2. So this is the pre-computation, and how I will use this pre-computation, I will tell you. Suppose I am checking for the length mid while in the binary search, mid in the binary search. Okay, so how I will check how I will count the number of the special substring of length mid. So suppose mid is equals to 2. Suppose mid is equals to 2, and I am checking for from the length for the special substring having character A. So I will iterate from for each length of the substring of character A. Okay, so what would be the count? So first is 4. First is 4. How many? Just tell me how many special substring of length mid, which is 2, can be possible with substring of length 4. How many? You can see it is 1, 2, and 3. So can I say that it is length minus mid plus 1, because 4 minus 2 plus 1, it is 3. You can see here 1, 2, and 3. So now I hope you got the intuition how I will check for the substring of length L. Okay, so for each character I will iterate for the length which I have pre-computed. For the length, I will iterate through the lengths which we have pre-computed from the string S, and will compute the number of the special substring of length mid. Okay, so let me write the code, then you will be more clear. Okay, so I am going for the unordered map. Corresponding to each character, we would be having a vector which would store the length of the substring having a particular character. Okay, now I will iterate to the string. Initially, the count would be 1 for each. Now, I will use another point, we can say iterator. Now, while j less than n minus 1, and if sj equals to sj plus 1. Suppose if j is less than n minus 1 and sj equals to j plus 1, means the two adjacent characters are same, then what I will do is that while j less than n minus 1 and s of j equals to s of j plus 1, I will do j plus plus and also count plus plus. Means what I am doing here is that suppose I am having a string like this B B B C C, then if these two adjacent characters are same, then I will keep a counter of this. So I will get correspondingly 4, here 3, and here 3. Okay, I hope this is clear to you. J plus plus, and then after coming out of this, I can say MP of SI dot pushback count, and I will set J is equals to I. Sorry, I is equals to J. Now I will apply the binary search. So the minimum length could be the minimum possible length could be 1, and the maximum possible length could be n minus 2. I have already discussed why the maximum possible length can be n minus 2. Okay, and I have initialized answer is equals to minus 1 in case if I have not get any special substring. So while low is less than equals to high, mid is equals to low plus high minus low by 2. Okay, so I will keep a bool variable and initialize it as false initially. Okay, now I will iterate for each character in the map and will go for which I have told you that I will keep a counter of the special substring of length mid we can get having character it dot first. Okay, now I will iterate through the vector corresponding to each character which is stored in it dot first. Okay, it dot second. See, it dot first is the corresponding character, and it dot second uh, it dot second mm, is the length stored in the corresponding to that character. Okay, if 2 is greater than equals to mid, then count plus equals to max of 0 comma mid minus 1. Mm, sorry, 2 minus mid plus 1. I have discussed how I am getting because the suppose we have been given a length len and mid is the length of the substring we want, then the number of the substring would be the number of the substring of length mid would be n minus len minus mid plus 1. So that's why I am doing like this. And if count is greater than equals to 3, then if the occurrence is greater than equals to 3, then okay is equals to true, means I have got this answer, and break. Okay, so if okay means at least I have got a substring of length mid which is satisfying this criteria that it should be having frequency at least 3, then answer is equals to mid in that case. And I will try for the greater length, mid plus 1, else high is equals to mid minus 1. Finally I will return answer. Means if there is no substring of length mid, so obviously I will have to like check for a smaller length than mid. Okay, so that's why I am doing else high is equals to mid minus 1. Let's just run this. Yeah, it is getting accepted. Let's submit it. See, it got accepted. So I hope the solution is clear to you. Thank you.